Okay, so on this question, we have a square root equation. So these are a little tricky. How do we handle it? Let me rewrite it. I'm gonna use an X because my T's end up looking like plus signs. So it doesn't matter what the letter is. Okay, so we have a square root and an equal sign. This chapter, chapter 2, has been about square roots. But this is the first time we've had a square root with an equal sign. You know what I mean? We have a left side and a right side, right? And our goal is to get X alone. X said, I want to be alone, right? So that means, X said, I want to be alone. Get rid of this root. Get rid of this 15 so that I can be alone. That's what we're trying to do, right? That's what it means to solve for X. It means to get rid of this stuff that's on the same side with the X. Okay, so how do we do that? Well, I'm going to do a second power on both sides. So step 1, parentheses second power to cancel the root. Second powers and roots are the opposites of each other. So when you second power something with a root, it just goes away. And the other side is 36. Because 6 squared is 36, right? 6 times 6 is 36. Is that making sense? Actually, you know what? That's true, but let me take it slower just to show you exactly why. I don't want, kind of like doing it almost like it's a trick. Let me show you. So it means this. First off, it means square root of X plus 15 times square root of X plus 15. And the other side means 6 times 6. Let's just do it a little slower, right? That's clearly what a 2 power means, right? It means 2 of them. Now on the next line, this means just 1 X plus 15 without any square root. Well, how do I know? And the other side is 36 because 6 times 6 is 36. Why? Why does that left side, why would you have 2 square roots of something? Does it end up being one of those with no square root at all? Are you familiar with that? Let me give you an example. What if I had square root of 3 multiplied by square root of 3? What would that equal? And that would equal square root of 9. And what is the square root of 9? Plain 3, no more root. You see what happened? Or another way, right, to see how 2 3s in a root led to what? 1 3 out of the root, didn't it? You see that? And that's because, remember what we've said about square roots? What are they? A 2-for-1 deal. 2 for 1. Let me go back and do it that way. How about if that'd probably be the easiest way for you to see it. Right? If you have 2 3s inside of roots, what does that do? Sends 1 3 out of the root, doesn't it? Remember, that's what square roots are fundamentally. They're a 2-for-1 deal. So that's what's happening here when you have 2x plus 15s in roots. That sends 1x plus 15 out of the root. So that's why that happens. So you don't have to show all these steps. For now, you can just do the shortcut. Notice I'll just go cancel right to there. Because it means 2 of them, and 2 of them in a root sends 1 of them out of the root. And that's true even for a big expression like x plus 15. Okay, so with that in mind then, now it's easy, huh? Once you get rid of that root, piece k, just go, yeah, okay. Just subtract 15 from both sides. Down. Boom, boom. So x equals, what's that, 21? And we're done. So that's the answer to the question, 21. So again, what do? When we have a square root, we got to get rid of it. How do we get rid of it? We 2 power both sides. And when you 2 power, 2 of anything in a root sends 1 of those out of the root. And the root is gone. It's a 2-for-1 deal. That's what roots are. The other side is just 6 times 6, 36. And then you just solve for x. So that's how we handle roots. At least the easy ones. There's more to it for the harder ones.